A random variable describes the probabilities for an uncertain future numerical outcome of a random process. If you understood this statement very good, you have a very good IQ. But let us understand it by splitting this. Let us first understand what is a variable. Here is a question for you all. If I flip a coin once, or if I flip a coin rather, what are the various possibilities? Head or a tail? Absolutely. I can either get a head or a tail. I can either get a head or a tail. So the output would vary. If the output varies, it is called as variable. If I roll a die once, what are the possibilities? What are the possible outcomes? There are six possibilities, absolutely. I can either get a 1 or a 2 or a 3 or a 4 or a 5 or a 6. So the output varies once again. I will not always get 1. I can get a 1 or a 2 or a 3 or a 4 or a 5 or a 6. So the output varies. The moment output varies, it is called as variable. That's the understanding of variable here. Second, let us now try to understand what is random. We call something as random if it has a probability or chance associated with each possible value. If I flip a coin once, what is the probability that I get a head? Anyone?
50%.
50%. So how did we get that? Head is only one event, so 1 out of total 2 events, 1 divided by 2. Probability of getting a tail is also 50% if I flip a coin once. So tail is one event out of 2 events. Head and tail are 2 events, right? So it will once again be 1 by 2, which is 50%. The moment there is a probability associated with each possible value, it is called as random. Now, what is the probability of I getting a 1 when I roll a die once? Absolutely. 1 is only one event out of total 6 events. What is the probability of I getting a 2 when I roll a die once? Again 1 by 6. Absolutely. 2 is just one event out of total 6 events. So it's probability or the count of event happening divided by the total possibilities. That would give you the probability. The definition of probability aside, what is random? If the possible outcomes have a chance or probability associated with, then you call that as random. And if the output values vary, you call it as variable. Hence, it is called as random variable. All right. Now, how many of y'all play cards? Yeah, only Harish plays cards, is it? No one else? Yeah. So most of y'all play, but a few of y'all are hesitant to speak up, maybe. Nothing wrong. Okay. So in a fair deck of playing cards, you would have in total 52 cards. Out of these 52 cards, you will have 13 cards of each variant. If you see, you have 13 cards of uh, what is this called as? Anyone? It is called as club. This is called as spade. This is called as heart, and this is called as diamond. Right? So you have 13 cards of each, and A stands to be 1, J is 11, Q is 12, K is 13. And you will have 4 variants of each card. You have 4 variants of A, you have 4 variants of 2, club, spade, heart and diamond, and you have four variants of each card there. If I close my eyes and if I randomly pick a card from a card deck of 52 cards, what is the probability that the card would be bigger than 10, greater than 10? 9 by 52, 52, P4, P3. So here, how many cards do we have which are greater than 10 when you look at this screenshot? I have J, Q, and K. These are the three cards which are bigger than 10. How many J do we have? One, right? Club, spade, heart, diamond. So you have four variants of J. We have four variants of Q. And we have four variants of K. So in total, you have 12 cards. So there are 12 possibilities of I getting a card which is bigger than 10 out of total 52 cards. So it's 12 by 52. This is how you need to calculate. Now let us try to solve this. What is the probability that if I randomly pick a card, it happens to be bigger than or equal to 10? Try out, friends. Okay, the right answer is 16. That's right. Equal to or bigger than 10. So we have 10, J, Q, and K. These are the four cards that we have. How many 10 do we have? Four variants. So I have four. For J also we have four variants. For Q also we have four variants. And for K also we have four variants. So if you add all these numbers, it happens to be 16. 16 out of total 52 cards. That's the probability of you getting a card which is equal to or bigger than 10. There is a reason why we are doing this, friends. What is the probability that you get a number which is smaller than 3? Please try, everyone. 8 by 52. Wow, great. We've been 8 by 52. How many cards do we have which are smaller than 3? Smaller than, not equal to. Mugdha, Asha, Harish, Tamuka, Abhijit, Sriram. Good. Most of you all have got it right. Whenever you see a capital representation, whatever be it, capital X or capital Y or capital W or capital A, B, C, whatever be it, these are called as random variables. We have already discussed about a random variable. So capital X here is a random variable. This capital X is the count of sales of large flat panel television set. When you refer to any statistical book on this planet, capital X would mean your random variable. Yeah, Manasa. Can you do one thing, Manasa? Can you just search for an option called switch to desktop version? I see that you have connected using web, GoToMeeting web. Where are you connecting from, Manasa? Is it US or India? Based on that, I can provide you a number. Okay, I think she's not able to hear. One second. All right, so here we go. Any capital representation would be called as a random variable. Here, capital X happens to be the sales of large flat panel television set. And all the values which this capital X can take would be represented using your small x. So this would be x1, x2, x3, x4, and x5. Please do not forget this, because moving forward you might want to refer to statistical books to accrue more knowledge. That is when you'd be stuck if you forget this. Capital X is a random variable, small x's are the values which this capital X would take. All right, so here is a table for us. Probability of selling 0 television sets is 40%. Probability of selling 1 television set is 25%. Probability of selling 2 is 20, 3 is 5, and 4 is 10% respectively. What is the probability of a sale? Yeah, please calculate this. What is the probability of a sale? 60%? All right. How did you get 60%? When do you say it's probability of making a sale? If we can sell more than one television set, greater than or equal to one television set. So if you sell one television set, that means you're selling something. If you sell two television sets, you're selling something. 3 and 4. So these 4 are the probabilities of you making a sale. If you add these probability values, what do you get? 0.6, which is 60%. Perfect. What is the probability of selling at least 3 television sets? No. At least 3 is what? Greater than or equal to 3 television sets. Probability of selling 3 television sets is 0.05. Probability of selling 4 television sets is 0.1. So the summation of these two would be what? 0.15, which is nothing but 15%. So there is a 15% probability of you selling a television set. Clear, everyone? Or do you have any doubts? Clear? No doubts? Perfect. Let us move on then. If I can represent all these events on the x-axis, event here happens to be the count of the television sets sold. If I can represent that on the x-axis, as in here 0, 1, 2, 3, 4, and if we can represent the probabilities on the y-axis, probabilities, right? Events on the x-axis and probabilities on the y-axis, if I can represent in this fashion, this representation is called as probability distribution. Extremely important, extremely pivotal, right? What is a probability distribution? Day in, day out, you'll be dealing with only this, friends.